Hi there, welcome back to the channel. Today I want to share a simple yet convenient improvement for the 5-axis 3D printer I've been working on. One benefit of sharing my project's progress here is that occasionally I get approached by companies willing to send me hardware. That is how Electro sent me this capacitive screen for the printer. So this video won't be focused on the 5-axis printing features, but rather a nice to have addition that will help me work on it. I will share some key learnings from this addition to my setup. I'll show you why I destroyed and resoldered the necessary cables, how I designed a snag fitting case, and how I configured the software on the Raspberry Pi to use the screen, even though I started with an Octopi image. Naturally, I had to deal with some deviations from the typical setups you will find online due to my modifications for the 5-axis use. So there is a bit of software, hardware, and design work in fusion. The first question you may have is, was this even necessary? Shouldn't you be focusing on slicing and making the printer work as intended? And yes, I agree, this shouldn't have been a priority. But it looks and works great, so I have no regrets. Once installed, it will help me operate the printer without constantly jumping to the computer. Don't worry, I have also been working on a custom board to improve the proving mechanism's precision, and I will share that as soon as it's ready. But this addition is complete and ready to be shared, while that's still in progress. Maybe shorter and more specific videos are better for some of you. Before we dive in, I want to give a big thank to my very first Patreon supporter, and to Electro for sending me this screen. Your support means a lot and helps me keep making these videos. Regarding the screen, my first impression is that it is of great quality. It's capacitive as opposed to resistive, like some others I've used in the past, so the touch operation feels smooth. It comes with several adapters to mount it with a Raspberry Pi on the back, fitting both Raspberry Pi 4 and 3 models. If you want to get your hands on one of those screens, please use the link in the description. It gives me a small kickback, which helps support the channel as well. So, without further ado, let's dive in. First of all, let me confess that I've overcomplicated this. The smart option would have been to use the screen as intended, mounted on top of the Raspberry Pi and then make a full case for it. But I wanted to keep the Raspberry Pi where, in my opinion, it belongs, at the back of the printer with the rest of the boards. So, I am not going to use the HDMI connectors that came with the screen. Instead, I am going to use a USB and HDMI cable. And, as always, I am going to do something a bit odd, which is to adapt the cables to my specific needs, purely for aesthetic purposes. Trashing cables and resoldering connectors is probably not what normal people choose to do with their time, but there are a couple of lessons to extract from the process too. This screen works with two cables, standard micro USB for the power and touch, and a standard HDMI for the display. I had two problems with this setup. Having cables protruding from the top and side ruined the look, and I wanted cables to be the same length. Instead of prioritizing functionality, I decided to rework the cables. I melted the bulky plastic covers, cut the cables to the desired length, and resoldered them. This allowed me to bend them tightly to fit a narrower case. There is always some risk with this approach. Shorting the wires or soldering incorrectly could damage the screen or the Raspberry Pi, but I did it partly for aesthetics and mainly to see if I could get away with it. Now I know I can shorten cables for specific scenarios. Step 1 is to melt away the plastic covering the connectors to expose the wires. I used my soldering iron for that, and it was easier than I anticipated. Then take pictures and notes to remember where the cables go, because they need to be resoldered in the same place. Lastly, to ensure resilience, secure the cables again. I used hot glue for that. Fortunately, it worked as expected. One important thing to note about the cables is that they have shielding, a metal sleeve that blocks noise. USB and HDMI cables use high-frequency signals that are susceptible to noise, which can corrupt the signal. The shielding keeps the noise out and protects the inner conductors. In HDMI cables, some pairs are even shielded from each other, so remember, shielding is important. Another thing I tried under the excuse of learning new things was to use the mesh design features in Fusion to make a cooler, more organic looking case. A key challenge is figuring out the best approach to design a model that needs to coexist with an existing part or board. Ideally, I would have a 3D model of the part I want to wrap. This would save me from measuring, making numerous prints that are off by millimeters, and then fixing, reprinting and retrying. Quite a frustrating process. Unfortunately, I had no 3D model to import. Although the manual indicates key distances, it misses some, like the positions of the volume and screen brightness buttons I wanted to leave exposed. Over time, I developed a workflow to handle this situation, which I would like to share. I am hoping someone watching can point out ways to make it more efficient, as it still takes considerable time. Another option I tried in the past is using a 3D scanner, but that didn't work well for me. My 3D scanner lacks the precision I need. I was never fully pleased with the results, so I stopped using it altogether. What I do nowadays is designing in small increments. I start by capturing the main features, print a draft of the shape, test the fitting, and once I am happy with it, keep adding features on top. This is much better than designing the whole thing, printing it, and being utterly disappointed when nothing fits as expected. While this workflow works, it's a bit wasteful in terms of time and material. I am eager to hear what you guys do when facing this issue. I am sure there must be a better way, I just haven't found it yet. So those are my iterations. The last step, once I had nailed down all the important features and measurements, was to make it look nicer. That's when I started experimenting with the form tools. I created a rounded box to wrap the ugly case I had, then adapted the mesh by creating bumps and lows to ensure all the desired features remain inside. Once I was happy with that, I duplicated the shape and thickened it. They can be later combined and subtracted from each other to get a consistent skin for the box. Finally, I chopped the parametric pieces I wanted to keep from my various iterations of the original box and combined them with my rounded case. The result was a win in my book. Now that I have experimented with this feature, I feel I've gained a new skill I can apply to other areas of this project or future projects. But bear in mind that printing organic shapes on an FDM printer is time-consuming and wasteful. A support is more necessary than ever. But what about another kind of printing technique? What about resin? Resin printers are a different animal altogether, so you will see more about it in my next video. Lastly, let's talk about the software. As I mentioned before, I started with a Raspberry Pi image that comes with Octopi pre-installed. That is the initial setup, but then I got persuaded by people in the comments questioning the use of Octopi as Klipper's interface. It seems Octopi is not the favorite interface nowadays, with the community preferring Mainsail or Fluid. Fortunately, this is something I can address relatively easily. As it turns out, Octopi is just an interface to control the actual firmware, which is Klipper, so there are no real restrictions here. I can keep Octopi and install other interfaces alongside it. Provided each interface runs on its own port, there should be no problem. To clarify a bit more, in any operating system, whether Windows or Unix based, there are background processes called services that perform specific functions to support other applications or system operations. Those services often start when the system boots and run continuously without user intervention. Klipper happens to be one of those services. Also, when we talk about interfaces, they are also programs, but the main difference is that interfaces provide a user-friendly screen for the user. They are often graphical or web-based, and behind the scenes they interact with services, in this case Klipper, through APIs or direct communication protocols. The interfaces send commands, receive status updates, and display information to the user, making it easier to control and monitor the 3D printer. To add a screen to this printer, what we are essentially adding is yet another interface to send commands to Klipper. When I plug the screen in the Raspberry Pi, it works straight away. It's just like plugging in a monitor. In fact, the screen is a monitor. However, it booted up in command line mode, so I decided to install a graphical user interface to test the touch screen operation. I executed some commands on the Raspberry Pi, which you can see on the screen. Once that was done, I needed to install additional software to make the screen initiate the right interface instead of the default Raspberry Pi desktop. The required software for this is Moonraker, a REST API web server for Klipper. It provides a means to interact with Klipper over a network, allowing for remote monitoring and control of the printer through web interfaces like Mainsail and Fluid. The second piece of software is Klipper Screen, which displays a dedicated interface on the screen. This combination allows the screen to show a specialized interface for controlling the printer directly. Installing Moonraker was not that straightforward. I had to edit a configuration file and move my Klipper configuration from its original directory to the one Moonraker required. This was a bit invasive in my opinion, but they have a good reason for it. The goal is to ensure a standardized setup that simplifies maintenance and troubleshooting, making it easier for various web interfaces and tools to find and interact with Klipper consistently. Lastly, I installed Klipper Screen, which works by using Moonraker's API. Once that was done, the screen was working as expected, but only after making some fixes to my custom branch of Klipper, which I have altered to use 2 more access. Moonraker was trying to invoke some commands on Klipper that I had not patched up yet, so I traced the errors by looking at Klipper's log files and fixed them as I showed in my previous video. I look at the error, identify the offending piece of code, figured out what was lacking or failing, and patched it up. So that's it, now the printer looks more like a 3D printer. I am super happy with this addition. It may not be a step forward into printing in 5-axis, but it's a step closer to having a device that I am proud of. Lastly, a piece of advice for anyone taking on this kind of project: get acquainted with Linux. It can be overwhelming at first, especially for Windows users, but it's incredibly important. Mastering Unix-like systems and their concepts is a huge advantage. Even Mac OS is Unix-based. In my opinion, few things are as powerful as the Unix command line. While I can share the steps, commands, and troubleshooting I did, things will likely change over time. Understanding the underlying concepts is key to adapting. This can't serve as a strict tutorial because the open source community evolves constantly, changing steps needed to achieve similar results. As always, thanks for watching and making it to the end of the video. If you'd like to support the channel, please share and subscribe, or consider joining my Patreon. It helps me a lot and enables me to create more videos like this. See you next time.